Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to focus on writing equation of lines, which has a high likelihood of appearing on the ASVAB. Before we do that, I just want to review a few things regarding lines before we get to the practice problems. First, I want to mention that these are all the forms for the equation of a line. A line can be written in slope-intercept form, where you have y equals mx plus b, and m is the slope, and b is the y-intercept. You can have a line that's written in point-slope form, where you have y minus y1 equals m times x minus x1, where m again is the slope, and x1, y1 is a point on the line. You can have a line written in standard form, which looks like this, ax plus by equals c. You can have a line written in intercept form. You can have a vertical line where x equals a, and a horizontal line where y equals b. For today's video, we're only going to focus primarily on slope-intercept and point-slope forms for the equation of a line. And similarly, we're also going to have to use our knowledge of vertical and horizontal lines to solve two of the problems. And we're really not going to talk about the intercept form of a line. That very rarely comes up when you're writing equations of a line. But that said, we are going to see some problems in which a line's given to you in standard form, and you're going to have to take that equation and convert it to point slope or slope intercept form. So let's break down a couple of these equations a little bit further. That way, when we get to the practice section of this video, you'll have a good understanding as to what we're doing. First, let's talk about slope-intercept form. Again, it's the equation y equals mx plus b, where m is the slope and b is the y-intercept. In case you forgot, the y-intercept is simply the point at which the line hits the y-axis or intercepts the y-axis. If you look to this graph on the right, we can see that this is our y-axis, and it spans vertically. So from here to here is the y-axis. And if you look at this line, it intersects the y-axis right here, namely at 0, 1. Okay? The slope of this line would be very easy to figure out. Again, in case you haven't seen it in a while, slope, which is referred to as m, is found by using this equation, namely y2 minus y1 divided by x2 minus x1, where x1 and y1 as well as x2 and y2 refer to ordered pairs. Again, that looks like this. You have ordered pair x1, y1, as well as ordered pair x2, y2. And you can simply pull those ordered pairs right off the line. In this case, let's use this one, this point on the line, as well as this point to find its slope. We can see that this point is at 1, 2, 3x and 3, 1, 2, 3y. So in other words, it's 3, 3. Whereas this point is at 1, 2, 3, 4, 5, 6x, and 1, 2, 3, 4, 5y. So this point, therefore, we know is 6, 5. Using the formula for slope, we can, now that we have two ordered pairs, we can simply use the formula given to find the slope. And again, if it makes more sense, and I like to do this too, you can simply label your ordered pairs. Call this one x1, y1, and this one x2, y2. And if we grab our slope formula, namely m equals y2 minus y1 over x2 minus x1. It's just a matter of plugging these values into this formula and solving accordingly. Let's go ahead and do that. Y2 is 5 in this case, and that's minus y1, which is 3. X2 is 6 minus x1, which is 3. Therefore, we have 5 minus 3, which is 2. 6 minus 3, which is 3. So in other words, the slope of this line is 2/3. Okay? Vertical lines are very easy to deal with. Again, they come in the form x equals a and y equals b. So you can have a vertical line that's this, x equals 5, and you can have a horizontal line that looks like this, y equals 3. How would we graph that? It's pretty simple. For the vertical line, we go to where x equals 5, 1, 2, 3, 4, 5, drop down a point, and then make our vertical line right over that point. And then for y equals 3, we go to 3 on the y-axis, 1, 2, 3, drop down our point, and make our horizontal line accordingly. Okay, so that is a high-level overview of the forms for the equation of a line. That said, there's a few other things I want to talk about before we get into today's video. And that is the fact that lines can either be parallel or perpendicular. If lines are parallel, that means they have the same slope, whereas if they're perpendicular, their slopes are negative reciprocals of one another. To illustrate that, let's say you had the equation of a line y equals 5x plus 2, as well as the equation y equals 5x plus 7. You can tell that these lines are parallel because, again, remember, we're working with the equation y equals mx plus b. And again, in case you need it, that is the slope-intercept form of a line. And we can see here, m is our slope, which corresponds to here and here. We can see that the slopes, 5 equals 5. In other words, the slopes are the same, so we know these two lines would be parallel to one another. Similarly, if I gave you the line y equals 5x plus 2, and then the line y equals negative 1/5 x plus 2, we can identify our slopes, namely 5 and negative 1/5. And since these two are negative reciprocals, we know that these two lines are perpendicular. Now that we've reviewed those topics, let's talk about exactly how we're going to write equations of lines. So for the ASVAB, you're going to have to be able to write an equation of a line in 3 different instances. You're going to have to be able to write an equation of a line when you're just given the slope as well as the y-intercept of a line. You're going to have to be able to write an equation when you're just given its slope as well as a point that's on that line. And finally, you're going to have to be able to write the equation of a line when you're just given 2 points on a line. As you can see, when you're just given the slope of a line as well as its y-intercept, you're given m and b, and you simply plug those two values into the slope-intercept equation of a line, and you're done. It's literally identifying what you have, plugging things in, and moving on. When you're given the slope of a line as well as a point that's on that line, you have 2 options. You can plug the slope as well as the values of that point in the slope-intercept equation, solve for b, and then take m and b and plug them into the slope-intercept equation. Or you can take the slope of the line as well as the point of the line, plug that all into the point-slope equation, and then solve for y. Okay? And finally, when you're just given 2 points that are on a line, you have to use first the slope formula to find its slope, and then you take one of those 2 points as well as the slope, plug it into the point slope equation, and solve for y. Okay, so we're going to get plenty of practice doing those things, so let's get started. Question 1 says, find the equation of a line that has a slope of negative 2/3 and a y-intercept of 4. So in this case, we're being asked to write an equation of a line given its slope as well as its y-intercept. That is, we're going to be following the steps in number 1 here to do so. And as I mentioned, you simply just identify what you have, namely m, as well as the y-intercept, which is b, and we're going to take those values and plug it into the slope-intercept equation, which is y equals mx plus b. Again, we know what m is, so let's plug that in. Y equals m. M is negative 2 over 3x. And we know what b is, it's 4. And that's it. That's all you have to do when you're given the slope as well as the y-intercept of a line to write an equation of a line. All right, so number 2 says, find the equation of a line that has a slope of 3 and goes through the point 0, negative 5. So to answer this question, we're going to be following the steps in number 2 here. And more specifically, I'm first going to use these steps to write the equation, and then I'm going to follow these steps to write the same equation to show you that they both in fact work. It's really a matter of preference as to which one you decide to use. But in this case, the first thing I want to do is identify what I have. I have the slope, which is m. Then I have the point, which I'm going to call x1, y1, right there. According to number 2, the first thing we have to do is solve for b. And to do that, we're going to plug our values into the slope-intercept equation, which is mx plus b. Again, we know what m is, so we can plug that in. And we know what our y and x are, so let's plug those in as well. Y is negative 5, so let's plug that in. M is 3, so let's plug that in. X is 0, so let's plug that in where we have x plus b. Okay, let's just work this out. Negative 5 equals 3 times 0 is 0. Again, anything times 0 is 0 equals b. So now we know what our b is. The next step in number 2 said to simply plug those values into the slope-intercept equation, which again is y equals mx plus b. We know what our m is, it's 3, and now we know what our b is, it's negative 5, so let's just plug those in. Y equals, slope is 3, 3x. We know what our b is, it's negative 5. And therefore, using the first part in step 2, we were able to write the equation of the line. The second half of step 2, our number 2 says, go ahead and plug everything into the slope-intercept equation. Not slope-intercept equation, the point-slope equation, which is this. Y minus y1 equals m times x minus x1. We've already identified everything, so all we do is have to plug things in and solve for y algebraically. So we have y minus y1's negative 5, so let's plug that in. M is 3, that was given in the problem. X minus x1 is 0. Okay, let's keep working this out. I'm going to deal with this right now. Y minus negative 5. Minus minus always becomes positive. So this is y plus 5 equals. Now I'm going to distribute this 3 to this x and this 0. 3 times x is 3x. Anything times 0 is 0. So that's going to be nothing. And now, according to number 2, we're just solving for y. That is, we want to get y by itself. So to do that, we're going to subtract 5 from both sides. This is going to cross out and leave us with y equals 3x minus 5. And as you can see, using both of the methods in number 2, we were able to come up with the same equation of a line. Okay, so it's really a matter of preference, but that's how you would do that one. Question 3 says, find the equation of a line that goes through the points -2, 0 and 0, -4. So if you recall, we're now working out a problem where we're going to need the steps from number 3 to solve it, or to write the equation of a line. And the first thing it says is to find the slope using the slope formula. Slope, of course, is m equals y2 minus y1 over x2 minus x1. And at this point, if you can't see it, go ahead and label your ordered pairs accordingly. I'm going to call this x1, y1, x2, y2. Now it's just a matter of plugging those things in. Y2 is -4 minus y1, which is 0. X2 is 0 minus x1, which is -2. Let's keep working this out. We have -4 minus 0 and 0 minus -2. Minus minus, of course, becomes positive. So this is -4 over 2. If we do the math, -4 divided by 2 is -2. Okay, again, a negative divided by a positive is going to be negative. So now that we've identified what our slope is, step 3, our number 3 says, go ahead and take your slope as well as one of the ordered pairs. It doesn't matter which one you pick, and plug it into the point slope equation. Again, the point slope equation is y minus y1 equals m times x minus x1. And so let's go ahead and plug things in. I'm going to use this ordered pair since I already labeled it x1 and y1. Could have used these values if you want it. Makes no difference. So y minus y1 is 0. So let's plug that in. M we found to be -2. X is just x minus x1. x1 is -2. Okay, let's go ahead and work this out algebraically. Now we're solving for y. That is, we want to get y equal to something. According to the order of operations, which are PEMDAS, you do what's in parentheses first, followed by exponents, followed by multiplication and division from left to right, and followed by, finally, addition and subtraction from left to right. As you can see here, we have parentheses. So let's go ahead and take care of that before we move on. We can go ahead and deal with this right here since it's not affecting anything. Y minus 0 is just y minus 2 times, and we have minus minus, which I mentioned becomes positive. So this is x plus 2. Now that we've worked out what's in parentheses first, we can move on to multiplication, which we have right here when we have to distribute this -2 to this x, and likewise this -2 to this +2. So let's go ahead and do that. Y equals -2 times x is -2x. -2 times +2 is -4. And now we've answered this question. That is, we've written an equation of the line given those two ordered pairs on the line. That said, it's always a good idea to check your work. To check your work, you can plug any of these two ordered pairs in this equation and see if it makes a true statement. So since I used this one already, I'm going to go ahead and use this one. And again, we're just going to plug that into the equation of the line we came up with, namely y equals -2x minus 4. Plug in things x and y where we see x and y accordingly. And this is negative 4. Sorry about that. So we have negative 4 equals negative 2. X is 0, plug it in, minus 4. We have negative 4 equals negative 2 times 0 is 0, negative 4. In other words, negative 4 equals negative 4. That is a true statement. Therefore, we're confident that the equation we came up for this to represent this line is accurate. Okay? Question 4 says, find the equation of a line that goes through the points negative 1, 6, and 3, 2, which is what we did in the previous problem. The first step, if you recall, is to find the slope using these 2 points. So we're going to use the slope formula to do that. Again, the slope formula is m equals y2 minus y1 over x2 minus x1. And if it's helpful, you can always label your ordered pairs before you proceed. I always do it so that I can stay organized. If I call this x1, that's going to mean this is y1. If I call this x2, this is going to be y2. So let's just plug those things in. Again, I call this y2, so that's 2, minus y1, which is 6, over x2, that's 3, minus x1, which is negative 1. Let's work that out. 2 minus 6 is negative 4. And 3 minus negative 1, minus minus becomes positive. So that's 3 plus 1, which is 4. That leaves us with negative 4 divided by 4, which is negative 1. In case you forgot the rules in regard to multiplying and dividing negatives, let me make a signs chart real quick. This is the signs chart. Let me just jot that down real quick. So the signs chart works for multiplication and division with for multiplication and division. More specifically, it says this: if you have a positive times a positive, the result's going to be positive. If you have a positive divided by a positive, the result's going to be positive. Similarly, if you have a positive times a negative, the result's going to be negative. Positive divided by a negative, the result's going to be negative, and so on and so forth. In this case, we have negative 4, which is negative, divided by positive 4, which is positive. So according to the signs chart, we know our result's going to be negative. Okay, so that's the signs chart in case you needed it. Now that we've found the slope for the equation of this line, the next step, if you recall, is to plug the slope as well as one of these ordered pairs into the point slope or the point slope equation, which looks like this: y minus y1 equals m times x minus x1. So let's go ahead and do that. Y minus y1. Again, I'm using this ordered pair. You can use either one of these once you get to this point. So y minus y1, that's our y in this case is going to be 2, equals m, which is negative 1, times x minus r3 for x1. So let's go ahead and work this out. The next step is to solve the equation for y. That is, we're going to try to get y by itself. So I'm going to take this negative 1 as my next step, distribute it to this x, and as well as the negative 3. Let's go ahead and do so. Y minus 2 equals negative 1 times x is negative x. Negative 1 times negative 3 is going to be positive 3. And in case we need to see that, let's take a look. We have negative times a negative, negative times a negative. We know the product is going to be positive. Okay, so the signs chart is useful to know. So let's solve for y. To do that, we're going to add 2 to both sides. This crosses out and leaves us with y equals negative x plus 2 plus 3. 2 plus 3, of course, is 5. So we've solved this by writing the equation y equals negative x plus 5. That said, it's always a good idea to check your work. And to do so, you can take one of the ordered pairs and plug it into the equation that you came up with. Since I used 3, 2 over here, I'm going to use the other one. So I'm going to use negative 1, 6 and plug that in. And again, we're plugging it into the equation y equals negative x plus 5. Again, this is our x and this is our y. And if this makes a true statement, we know our equation works. Y, of course, is 6. X is negative 1, so this is negative of negative 1 plus 5. 6 equals negative times negative. This becomes just 1 plus 5. 6 equals 1 plus 5 is 6. True statement. So we know that this equation that we wrote to represent the line that passes through these two ordered pairs is in fact correct. Okay, so we know we got this one. All right, number 5 says find the equation of a line that goes through the points negative 8, 5, and negative 6, 4. Again, right away, I'm going to call this x1, y1, and I'm going to call this x2, y2, just so I have that ready. If you recall, we're working to solve this one, we're going to use the steps that I mentioned for number 3, where we have 2 ordered pairs on a line. So the first thing we're going to do is find its slope using the slope formula. That is m equals y2 minus y1 divided by x2 minus x1. We already labeled those, so it's just a matter of plugging things in. Y2, as we can see, is 4 minus y1, which is 5. Our x2 is negative 6, and our x1 is negative 8. So let's go ahead and work this out. 4 minus 5 is negative 1. Negative 6 minus negative 8. Again, a negative and a negative is positive, so this is negative 6 plus 8, which is just going to be 2. So we can see our slope is going to be negative 1/2 in this case. So if you recall, the next step in the process is to plug in one of these ordered pairs as well as the slope in the point slope equation, which looks like this. Y minus y1 equals m times x minus x1, and solve for y, that is to get y by itself. It doesn't matter what order pair you plug in. I'm going to use this one since the numbers are smaller. So again, y minus y is 4 here equals m we found to be negative 1/2 times x minus our x1 in this case is negative 6, so that's negative 6. Again, according to the order of operations, namely PEMDAS, we do what's in parentheses first, exponents next, multiplication and division from left to right, addition and subtraction from left to right. In this case, we do have something in parentheses to deal with, and then we'll move on to multiplication. As far as the parentheses go, we have to address this negative. As we know, that's going to simply become positive. So let's write that accordingly. Y minus 4 equals negative 1/2 times x plus 6. Okay, so we've dealt with what was in parentheses. Now we're going to take this 1/2 and distribute it there as well as there. So y minus 4 equals negative 1/2 times x, which is just negative 1/2 x, as well as negative 1/2 times 6, which is going to be negative 3. Okay, again, half of 6 is 3, and it's negative times positive, so we know it's going to be negative. Let's add 4 to both sides to get y by itself, and that leaves us with the equation y equals negative 1/2 x plus 1. So this is the equation of the line, but that said, let's go ahead and check it to make sure we did things correctly. Again, to check it, you take one of the ordered pairs. I'm going to use negative 8, 5 in this case, and you plug it into your equation. Again, this is our x and our y. And our equation is y equals negative 1/2 x plus 1. If this makes a true statement, we know that we did this problem correctly. Y is 5, negative 1/2. X is negative 8 plus 1. 5 equals negative 1/2 times negative 8 is going to be positive 4 plus 1. 5 equals 4 plus 1, which is 5, which is a true statement, which means that we wrote the correct equation of this line that passes through these 2 points. Okay, so that was that one. As you do these problems, you can tell that you have to be pretty good with basic arithmetic rules. You have to know the order of operations, for instance, as well as how to deal with multiplication and division involving negatives and positives, as well as addition and subtraction involving negatives and positives. And finally, you have to be good at dealing with fractions mentally. All right, number 6 is a little bit challenging at first glance, but as you'll see, it's pretty straightforward. It says find the equation of a line that is parallel to the x-axis and goes through the point negative 4, 7. So before we get into solving this one, let's think about what we're doing real quick. And I'm going to do a rough sketch. Okay. It says find the equation of a line that is parallel to the x-axis. This is the x-axis. And if any line that's parallel to the x-axis is going to be a horizontal line, okay? And if we go back to the very beginning when I gave us an overview of some basic concepts, we talked about horizontal and vertical lines. In this case, we have the equation y equals b to represent a horizontal line, where b is the y-intercept, that is where the line intersects the y-axis. So let's go back to this. Again, we know we're dealing with a line that's going to look like this, y equals b. Okay? So as long as we know we're dealing with a horizontal line, we just have to figure out what that b is. And in this case, it's where the line intersects the y-axis, and it's going to do that right here at negative 7. Okay? So if I go to negative 7, which is down here, we can see that the line is going to look like that. And it intersects the y-axis at, goes through the point negative 4, 7. So here's negative 4 and then negative 7. That is on the line. So that's it. We've done this one. We simply had to recognize that we're dealing with a horizontal line, which is going to be of the form y equals b. And similarly, we just had to say to ourselves that b is going to be negative 7, which is just a y value in the ordered pair. Okay, so that's all you have to do for those. Number 7 says find the equation of a line that is perpendicular to the x-axis and goes through the point 4, 8. So this is just the opposite of what we did. Let's go ahead and think about what we're doing real quick, because there's not much math involved in solving these. We want a equation of a line that is perpendicular to the x-axis. Again, this is the x-axis. If something's perpendicular to it, it's going to look like this. That is, it's going to be a vertical line. So we know we're dealing with a vertical line, and that's going to be of the form x equals a. So we know our answer is going to look like this, x equals a. And all we do is have to take our x and set that equal there, and we're done. And again, if we want to graph it, let's go to x equals 4, 1, 2, 3, 4. And we would just drop the vertical line right there. And the point 4, 8 would be somewhere up here. So that's it. As far as horizontal and vertical lines go, that's all you have to do. You just have to remember y equals b, x equals a. Plug in your x value for this one and plug in your y value for the other one, and you're done. So that was that one. All right, number 8 says, find the equation of a line that is parallel to 2x minus 4y equals 7 and has a y-intercept of 4. Okay, so this problem is going to be pretty challenging insofar as it's going to combine pretty much all the concepts that I've mentioned in this video so far into one problem. First, I want to point out that this equation is given to you in standard form. That is ax plus by equals c. And one of the challenges of this problem is we're going to have to go from standard form to slope-intercept form, which is y equals mx plus b. Okay? It's fairly easy to do that, but similarly, another challenging part of this problem is the fact that we have to use our knowledge of parallel and perpendicular lines as far as their slopes are concerned to find the slope in this case. Okay? And if you remember, I did quickly mention that parallel lines have slopes that are the same, whereas perpendicular lines have slopes that are negative reciprocals of one another. So in this case, we're told that the equation of the line we're going to write has a slope that's parallel. So what we're going to have to do is first rewrite this equation from standard form to slope-intercept form, identify what its slope is, and then write the equation of the line. So let's go ahead and do that. Again, we're dealing with the equation 2x minus 4y equals 7. That's given to you in standard form. And we want to take that and write it in slope-intercept form. That is, we want to solve this equation for y. We want to get y by itself. First thing I'm going to do is subtract 2x from both sides, and in doing so, this crosses out and leaves me with negative 4y equals negative 2x plus 7. Again, we're still trying to get y by itself, so I'm going to divide both sides by negative 4. This will cross out, leaving me with y, which is in slope-intercept form. We have negative 2 divided by negative 4. A negative divided by a negative is going to be positive, so that's going to be 1/2 x. Again, 2 over 4 reduces to 1/2. And we have 7 over negative 4, which is the same as negative 7 over 4. So from here, we've rewritten this equation into slope-intercept form, which will allow us to identify our slope. It's right here. It's m equals 1/2. And we were given a y-intercept, or b, of 4. So all we have to do, if we remember what number 1 said above, number 1 said identify your slope and identify your y-intercept, and then plug them into the slope-intercept equation, which is y equals mx plus b. Plug in your slope and y-intercept accordingly. Y equals m is 1/2 x plus b, which is 4. So in other words, this line is parallel to this line, which looks like this, and slope-intercept form. So these two lines in other words, are parallel, and this would be our answer to the question. Again, you can see the slopes are the same. We have our y-intercept, and we're done. Okay? So this last problem is very similar. It says find the equation of a line that is perpendicular to 6y minus 3x minus 2 equals 0 and goes through the point 4, negative 3. Again, this one is given to you almost in standard form, but it's not really in any form at this point. So what we're going to do is take this equation, write it in slope-intercept form, which is y equals mx plus b. We're going to use the fact that it's perpendicular, which means that its slope is going to be a negative reciprocal. And then we're going to use the point to write the new equation of the perpendicular line. So let's go ahead and do that. We have 6y minus 3x minus 2 equals 0. Again, you want to solve for y. That is, you want to put this in slope-intercept form. So what you can do is you can add 3x plus 2 to both sides. That will cross this out and leave you with 6y equals 3x plus 2. And then you want to go ahead and divide everything by 6 to get y by itself. This will cross out and leave you with y equals 3 over 6, as you should know, is the same as 1/2 x plus 2 over 6, which is the same as 1/3. Okay, so we basically took this equation of a line and wrote it in slope-intercept form. We can see that the slope of this line is 1/2, and the equation of the line we're trying to write is perpendicular to this, so it's going to be a negative reciprocal. So in other words, we want to find the reciprocal, the negative reciprocal of 1/2, which means you just flip these and add negative. It's going to be negative 2 over 1, which is the same as just negative 2. Okay, so our new slope for the equation we're trying to write is going to be negative 2. And now we're moving on to number 2 above to solve this one. And if you recall, we have two options. We can plug the point as well as the slope into the point slope equation and solve for y to write the new equation of the line. So that's what we're going to do. Again, the point slope equation is this: y minus y1 equals m times x minus x1. Okay, and here's our x and our y that we're going to plug in. We found our slope. So y minus negative 3 equals m is negative 2 times x minus x1, which is 4. Solve. Again, let's deal with this real quick. Minus minus is just positive, so this is y plus 3 equals negative 2. We're going to distribute this to this x as well as this negative 4. Negative 2 times x is negative 2x. Negative 2 times negative 4 is going to be positive 8. Okay. And now we're just solving for y, so we're going to subtract 3 from both sides. And that gives us y equals, this crosses out, negative 2x. 8 minus 3 is 5. So we have this equation of our line that is perpendicular to this line. And as you can see, their slopes are in fact negative reciprocals of each other. And so that's that. So that's all I have for you in this video. I hope you found it helpful. Admittedly, this video covered a lot of different concepts. So if you found it challenging, that was the point. In my opinion, too many people on YouTube just post easy ASVAB questions without really challenging people. whereas I take very basic concepts in the beginning and build on them throughout the video, which is why my videos are a little longer than usual. So feel free to subscribe to my channel if you want more content like this. In addition, it's always helpful when I receive positive feedback in the comment section below. But on that note, I'll go ahead and cut you loose.
こんにちは。